So take a look at example 1. We want to graph the following functions using our knowledge of the parent function and the transformation rules. So the parent function is graphed in blue there. That's the parent function. And then here is the transformed quadratic. So what's helpful is if we list the transformations. So we have this negative on the outside here. So that means we did a reflection over the x-axis. And I'm going to put it under this first graph because that's what we're going to do first. Reflection over x-axis. And then the next transformation we did was we're adding on the inside, so that means we go left. So we did a reflection over the x-axis, we went left 5, and then we have this subtraction on the outside, which is our vertical movement, so that means we went down 2. So we're going to graph each of these transformations on each grid, and then below I'm going to show you how you can do this in one step. And then you can do this in any way you prefer. If you want to do in one step, do it in one step. If you like doing all the individual steps, do all the individual steps. So we have our first transformation, which is a reflection over the x-axis. So when we reflect over the x-axis, the parent function, the vertex stays the same. But instead of counting up, we count down. So we're going to use that counting pattern. We go down 1, right 1, down 3, right 1, down 1, left 1, down 3, left 1. And there is the parent function reflected over the x-axis. Then we're going to move the reflected graph, and we're going to move it left 5. So again, the vertex just moves left 5. And then you keep that same counting pattern. We went down 1, right 1, down 3, right 1, down 1, left 1, down 3, left 1, and then connect. And then our last one, we went down 2. Again, our vertex moves down 2 from where it was, so it's at 5. I'm going to keep it where x is -5, but just move it down 2. And then keep that same counting pattern. Down 1, right 1, down 3, right 1, and down and left, down and left. And there we go. There is the transformed graph. That's how you can do it in all the individual steps. So if you like that method, do that method. If you want maybe a quicker method, what you can do is graph it kind of all in one grid, in one step. So your first thing to do is graph the vertex. So if we look, our vertex, we're adding on the inside, so that means change the sign, it's negative. Subtracting there, keep it the same. So our vertex is at -5, -2. So go ahead and plot that. The parabola is opening down, so that means we're going to count down. Okay, and then there's no stretch or compression, so we don't have to worry about that for this problem. So you just plot your vertex. We did a reflection over the x-axis, so you just count down 1, right 1, down 3, right 1, down 1, left 1, down 3, left 1, and as you can see, this blue graph is the same as our final orange graph. So again, if you need to do it in multiple steps, do it in multiple steps. But if you liked how to do everything in one step, that's fine too, whichever one works for you. So we take a look at example 2. Again, we have our parent function. Here's our transformed function. And I'm going to list the transformation. So we have this -1/2 in front. It's less than 1, so that means we did a vertical compression. I think there might be more space for me to write it at the top. Vertical compression by 2. And please write actually compression. I just ran out of room to put that, but we ask you not to abbreviate. And then we have this minus sign on the inside, so that means a reflection over the y-axis. So we have a reflection over y-axis. And then we're subtracting on the outside here. That means we go down 4. Oh, and I said by 1/2, not 2. So when we compress by 1/2, there's multiple ways to compress by 1/2, but our vertex stays the same. So we are compressing our parent function by 1/2. So one way to do it is just to multiply the y values of the vertex by 1/2. So here, our first y value is at 1, so that point becomes 1 in 1/2. Just kind of estimate. The next y value there is at 4, so 4 times 1/2 is 2. And same thing, this one's also going to be at 1/2, and the next one's also going to be at 2. Kind of mirrors each other. And then connect. So there it is, compressed by 1/2. Then what you're going to do is take the new compressed graph and reflect over the y-axis. But whenever the vertex is sitting on the y-axis or sitting at the origin, when you reflect it over the y-axis, nothing changes. So it's just going to stay exactly where it's at. So you're going to replot the same graph from before. Oh dear. Plot this a little bit better. Okay. And then the orange graph went down 4. And we do that counting method, as you can see. We went up 1/2 over 1, and then we went up 1.5 over 1 to get to the next point. So just follow that pattern. Up 1/2 over 1, up 1.5 over 1, up 1/2 over 1, up 1.5 over 1. And then connect. So it should look like that. Now, to do this in one step, again, what you want to do, plot your vertex. And that's where we're starting. And our vertex is 0, -4. We're not adding or subtracting anything on the inside with the x, so our x value is 0. And then the y value is -4. Then, is the parabola opening up or down? Well, we didn't reflect over the x-axis. So it's going to stay open up. And again, whenever you reflect the parent function over the y-axis, nothing changes. So it just stays where it's at. And then there was a compression by 1/2. So it affects the pattern by multiplying the pattern by 1/2. So our normal pattern is to go up 1 over 1, up 3 over 1. Well, you multiply that distance by 1/2. So instead, we're going to go up 1/2 over 1, up 1.5 over 1. And there we go. And again, it looks the same as that green graph. If we take a look at problem 3, here's the parent function, here's the transform function. We're going to do it in multiple steps and then do it in one step. So our first multiple step, our first one, we have that negative out in front, so it's a reflection over the x-axis. And then we are going to do, we have that 2 here. It's bigger than 1, so we have a vertical stretch by 2. And then we're adding the 5 on the outside, so that means it's going to go up 5. So again, when we reflect over the x-axis, the vertex stays exactly the same. You just count down. So we're going to go down 1 over 1, down 3 over 1. Same thing, down 1 over 1, down 3 over 1, and connect. So it'll look like that. Then we're going to take the reflected, that green graph, and do a vertical stretch by 2. So again, when we count, there's 2 ways to do this. You can multiply all the y values by 2 and graph them, or you could do this counting method. Again, we went down 1 over 1, down 3 over 1. When you do a vertical stretch, you're just multiplying that distance by that number in front. So we're multiplying it by 2. So our vertex is going to stay exactly where it's at, but instead of going down 1, we're going to go down 2 over 1, and then down 6 over 1. Down 2 over 1, down 6 over 1, because we're multiplying the distance by 2. 1 times 2 is 2, 2 times 3 is 6. Then we're going to take that purple graph and move it up 5, so everything just goes up 5 units. And when that happens, it will look like this. So your final graph should look like that. So again, how we would do this in one step is, again, plot the vertex. So our vertex is at 0 again, 5. We're not adding or subtracting anything with the x, which is 0, 5, so plot that. We're opening down because there's a negative out in front. We reflected it over the x-axis, and there's a stretch. So we're multiplying the distance that we count by 2. So you can go ahead and graph your vertex. And again, our normal distance would be down 1, right 1, down 3, right 1. But we're multiplying it by 2. So now we're going to go down 2, right 1, down 6, right 1, down 2, right 1, down 6, right 1. And there we go. Again, whichever way works for you. If you like to break it down in 3 steps, do it in 3 steps. If you like to do it all in one, by means, do all the steps in one. And then last one for this video, there's the other video with the rest of the problems. List your transformations. So we have that 3 out in front, so that means a vertical stretch. So we have a vertical, because it's bigger than 1, it's a vertical stretch by 3. And then we're minusing on the inside, so that means we're going to go right, think opposite. We're going to go right 4. And then we have the plus 1 on the outside, so we're going to go up 1. So again, when we do a stretch, your vertex is going to stay at the origin, and we're still opening up because there's no reflection. You just multiply that distance. So normally we go up 1, right 1, up 3, right 1. Now we're going to multiply that distance by 3. So we're going to go up 3, right 1, up 9. But when we go up 9, because again, the distance from here to here is 3, and 3 times 3 is 9, we go off the grid. So we're not going to graph it. So this one, all we have to do is go up 3, right, left 1. And there's the graph stretch. Then we're going to move that orange graph right 4. You're going to keep that same pattern, up 3, right 1. And then we're going to move it up 1. And then all the other points just move up 1. So it will be located here. So again, to do this in one step, plot your vertex first. Our vertex is 4, 1. It's opening up because there's no reflection, and we have a vertical stretch, meaning that counting distance is increased or multiplied. So normally we go up 1, right 1, but 1 times 3 is 3. So we're going to go up 3, right 1. And then the next distance would be up 3, right 1, but again, 3 times 3 is 9. We're going off the grid. So we just have to do this one distance. And there we go. Same exact graph as the last one there.